Okay, now I've got a 22 meg ohm resistor in there. Now looking at the ranges for resistance, I see the maximum resistor it can read is 1100K, 1.1 meg. So it looks like we'll have to switch to the conductance mode for that. And you can see our capacitance Q light has come on. And micro mhos. And as you turn this, also the units change. There's millimhos, micromhos, all the way down to nanomhos, or nanosiemens as you'd call it today. And sure enough, my one of my Fluke DMMs has a nanosiemens scale too. And in fact, I tried this a bit earlier, and the result I got from the bridge was pretty much identical within about one count of the DMM. So this either they're both wrong or they're both quite accurate. So once again, we need to look for a null. So first of all, we'll go for a coarse one. It looks to be the best range. And there is about where we want it. Yeah, that's looking somewhere in that range for the null. Bump up our gain. Try that again. Okay. Right about there. So that's reading 44.3 nanomhos, or nanosiemens, which works out pretty close to 22 meg. It's just the inverse of the resistance, of course. Now let's see what we can do with this Q dial. And if I recall correctly, when I tried it last time, I got a kind of maybe a misunderstanding what Q means in this case, because the reading didn't seem to make sense. But let's see what we can do. Again, we'll watch the meter. Okay, looks like so this is actually two rotary switches and just a continuous, probably capacitor, variable capacitor. And it's reading point something, something, something. So we're talking Q's below 1. I think I can go a bit above 1. Yeah, 1.2, I guess. Anyway, you can see we're getting closer to the null. Just past it. Aha. So there, that seems to be our null. Let's go back to here. Ooh, yeah, even better. Okay, so there's our null for the resistance or conductance value, 44.5 nanomhos. May as well use the right, properly dated terminology. And if you look at the Q, let's just try that again to null it out. Right about there. We're reading 0.064, Q of 0.064. My understanding is that would I think it would be the reactance of any shunt capacitance across that resistor divided by the resistance. But when I calculated that yesterday, it came out to something like 100 puff, which is obviously way too high. I mean, the shunt resistance is probably more like 1 puff. So I will do those calculations again and maybe hit Wikipedia or something like that and see if I can't understand correctly what the Q should be in this case, how it's defined. So either I got it wrong, or maybe the box itself has a problem measuring that. But given everything else is working so well, I'm thinking it's me. So there, that is an example of a high-value resistor. I've also got a couple of wire wound parts. And let's start out with this one. This one is marked 2.7K, so that's fairly high value for a wire wound. Stick that in there, and we'll switch over to resistance mode, of course. And you can see I picked wire wounds, of course, because they're known to be inductive, and figured they would have the best chance of providing some sort of interesting reading on the Q dial. So once again, let us narrow down our settings here. Okay, appears to be the right range. Or not, maybe not. Let's try this. Yeah, here we go. Okay, we're in the ballpark. What about Q? Yep, sure enough, that's helping out with the null. And okay, this thing is most nulled at a Q of 0. Let's come in a bit better on the value. Okay, right about there. So we're reading 2.549K. So you can see this is quite accurate. It's more accurate than a lot of DMMs would be, at least in this range and in this mode. Try this again. Pretty much 0. So the at 1 kilohertz, whatever the inductance of this resistor is, it's not terribly significant compared to 2.7K, which I guess is not too surprising. Which is why I've also got a much lower value resistor, and this one is marked at 0.22 ohms. I don't know if that's visible. 5 watts? Yeah, 5 watts. So let's try him or her, I'm not sure. Oops. Okay, I guess I could have put clip leads in there, but this is nice and accurate and close to where it's going to be measuring. Okay, we're still in resistance mode, that's good. But obviously our range is going to be way out. So that seems to be where we want to be. And yep, that's pretty close. Okay. Okay, now let's go back to the infamous Q dial, and sure enough, this time it has something greater than 0. Now would this be still called Q? I guess so. Q, inductive Q. Anyway, we can think about that later. So okay, we're homing in here on the null setting, and that's about it right there. So our reading is 239.6 milliohms. So there, that's try and do that with your DMM. That's a nice accurate. And one assumes it has 4-wire sensing internally, so whatever extra resistance we're seeing there is just whatever, few milliohms that these binding posts have. Okay, bump up the meter again, and it looks like our Q is around 0.0065007, say. So Q in this case would be what? It would be the inductive reactance over the resistance, and the reactance obviously is comparable to the other resistor, the 2.7K we already tried, but because the resistance is 10,000 times lower, roughly, than the inductance now has a small effect compared to the resistance. Obviously at higher frequencies that would become more of a problem, but there you go. I think that just about covers it. This gorgeous ancient, what's the model number? 1608A, I think? Serial 695. There you go. There's the best way to measure your inductors and capacitors.